Okay, so hello everyone. So our today's topic will be adding and it's gonna be adding and subtracting unlike rational expression. Okay, is unlike rational expression, which means their denominator are not the same. Okay, denominator is not the same. Okay, so before we actually doing some questions, there are some really important things we have to introduce to you guys. So the really important thing over here is the least common denominator. Okay, just the least common denominator. We can actually simplify this by LCD. Okay, so let me give you guys some example. Some example on the right hand side. Okay. So some example. Let me think. So I'm just gonna make something up. Okay. So we have something like 5x squared. Okay. And then we have another one is maybe 6x to the power 4th. Okay. So usually if we want to find the least common denominator, so we need to have at least two terms. Okay, we need to have at least two terms. That's the minimum. We need to have at least two terms in order to find the least common denominator, LCD. Okay. So suppose we have something like this. Okay, we have 1 over 5x squared, and then we have another term is 1 over 6x to the power 4th. Then, we want to find the least common denominator, right? So let's focus on the variable first. Okay, so you can see over here we have 1x squared, and then we have another x to the power 4th. So obviously you know that the least one will be x to the power 4th, right? It cannot be x to the power 2, cause because we want to find the least common one, right? We want to find the least common denominator. It have to be a common one. So therefore we have to choose x to the power 4th to be the least, right? If we choose x to the power 2, then that just does not make sense, right? Okay, so now we find the least common denominator for the variable. Now we focus on the number. Okay, so you can see the number over here. What we have is 5 and 6, right? We have the number over here is 5 and 6. So the most easy way to actually find the least common denominator is just simply multiply them. Okay, which is 30 in this case. Okay, that's the most easy one, cause you can see, to break into the detail. Okay, so you can see for 5 we can only have 5 multiplied by 1, right? And then for 6 we can have 1 multiplied by 6, and then 2 multiplied by 3. And you can see over here, we can see there's actually no common factor. There's nothing in common between 5 and 6, right? So that means the least common denominator have to be 5 multiplied by 6, which is 30, right? Okay. So one thing I want to say is that you can see over here. Let me repeat again. Okay. So you can see between 5 and 6, there's nothing in common. 5 is equal to 5 multiplied by 1, and 6 is equal to 1 multiplied by 6, or 2 multiplied by 3, which you can see, just no number is common in 5 and 6. That's why the least common denominator have to be 5 multiplied by 6, which is 30. Okay, which is 30. So this term 30 x to the power 4 have to be the least common denominator among those two terms. Okay, among those two terms. Okay. So now I already tell you guys how you actually find the least common denominator. Let's actually move into the question to demonstrate some, okay. Let's just basically move into the question to actually demonstrate how we actually apply it. How by knowing this we can actually solving some problem. Okay. So we got totally safe question over here. We got totally safe question. So if you solve the question, if solve the question is easy for you, then feel free to skip it. Otherwise, I will go through all the question in detail. Okay. So let's move into question 1. Again, so you can see over here we have a 12 and then we have a 9. So you can see those are not the same, right? I mean the denominator are not the same. So that means we have to find the least common denominator in order to simplify it, right? So we want to have the same denominator. That's what you're thinking. Okay, so first thing you want to have the same denominator. If you actually want to subtract it, and between 12 and 9, right? So you want to find what is the least common denominator between 12 and 9, and you can see 12 is actually equal to 3 multiplied by 4, right? And then 9 is actually equal to 3 multiplied by 3. So you can see we have a 3 in common, right? We have a 3 in common, and then we have 4 and another 3 is indifferent, right? So the easy way to actually find the least common denominator is just basically simply multiply by 3 over here, and then you multiply by another 4 over here, right? And then it turns out it's gonna be 36, right? Okay, so that's basically a trick. Okay, you see here 3 and 3 they both have common, and then you see this 4 and then this 3 are different, so you just flip it. Okay, that you just kind of like flip it, swap it, and then you multiply it, and then you get the same. So now you know LCD 36 will be the LCD between 12 and 9. Okay. So now let's continue. Okay. So you may say, now I know the least common denominator. How is that related to solving this problem? Right. So now I will tell you why is this related to actually solving this problem. So make sure you really know that, because over here we actually multiply by 3 on 12, right? And then we multiply another 4 on 9, right? So you have make sure you keep in mind. So the thing what we have to do over here is we multiply 3 over 3, okay, and you multiply 9 over 4, we multiply a 4 over 4. That's really important. So a lot of people, a lot of people getting the wrong answer, cause you gotta have to make sure it is balanced. Okay, you want to make sure it is balanced. It is balanced. Okay, you want to make sure it is balanced. Okay, you want to make sure that. That's why you multiply 3 over 3 and then 4 over 4. Okay, a lot of people, like they get the wrong answer. They get the wrong answer. Let me actually. It's kind of like a mess. A lot of people actually making the wrong answer just simply because they didn't actually balance it. If you actually multiply 1 over 3 and then 1 over 4, it's actually not balanced, right? So you want to make sure it is balanced. Okay, you want to make sure it is always it's not 3, it's actually 4. You want to make sure the equation all the time is balanced. So that's why you multiply 3 over 3, which is 1, and then 4 over 4, which is 1. So it's still balanced, right? So that's how you actually getting the right answer. So 12 multiplied by 3 is 36, and then 7 multiplied by 3 is 21, and then you minus 36. 4 multiplied by 9 is 36, and then 4 multiplied by 4, which is 16. So now you can see we have the same denominator. So we are actually able to apply the property, right? So we have 21 multiplied by 16. Sorry. Now is 16. Okay, over here. So now we have 36. We have 36 as the denominator, and then we have 21 minus 16, and then we have 36 on the bottom, and then on the top we have a 5, right? On the top we have a 5. Okay, so now this is actually the final solution for this problem. Okay, so you keep in mind, you want to make sure it is always balanced. Okay, so let's move into question number 2. Okay, as I already really well explained the question 1, I think we are actually doing those questions a little bit faster. Okay, as always, you want to find the least common denominator. Over here, for the variable, we have b to the power 3 as the least common denominator, and then between 4 and 3, 4 is actually equal to 4 multiplied by 1, and 3 is multiplied by 3 multiplied by 1, which you can see there's nothing in common. So you know that the least common denominator will be 4 multiplied by 3 b to the power 3, right? It's kind of like a little mess. So let me actually, okay. So now you know the least common denominator will be 12 b to the power 3, right? Okay. So now you know the least common denominator will be 12 b to the power 3. So let's move into the process, how we actually using the LCD to actually solving this problem. Okay, so 4b squared 3, and then here, so here you want to make sure it is balanced, right? So let me actually, okay, so you want to keep in mind with those, because right, you guys get it, right? So on 4, right, on 4, on 4, right? So we actually have to multiply by 3. So we have multiplied by 3, and then you can see we have a 4b squared, and then 4b squared, right? So we have a 4b squared, and so that means we have to multiply a single b. So that's why we have a b over here, right? So you want to make sure it's always balanced, okay? And then on the other side, delete it. On the other side, you can see we have to multiply by 4, right? To make both of them, both of the denominator have the same denominator, right? So you may ask me why you only multiply 4 over 4 on 3b to the power 3. Why you don't multiply another b? Because you can see over here we have a b to the power 3, and then that's the same thing as b to the power 3, right? So the thing you need to multiply over here is just a single 4 over 4. Okay. So now let's finish. So now let's finish the rest of the process. Okay. So you can see 4 multiplied by 3 is 12 b to the power 3, and then on the numerator what we have is 3 multiplied by 3b, which is 9b, right? 3 multiplied by 3b is 9b. And then on the other side you can see you have 3 multiplied by 4 is 12 b to the power 3, and then 5 multiplied by 4 is actually 20, right? So now you can see we have the same common denominator, right? So keep in mind, you always want to make sure it is balanced, okay? Because the way how we actually solving the problem is that we need to have the same denominator. We need to have the same denominator, right? We need to have the same denominator. If we don't have the same denominator, so we are actually we are not able to do, and we are not able to apply any property, right? We're not able to apply any property, right? Okay. So now you can see is that we have 12 b to the power 3, and then on the top we have 9b plus 20, right? So on the top we are actually doing addition. So we have 9b plus 20, okay? And then you take a final look. You see, is there anything you can simplify it, and the answer is no. Okay, so you take a final look. Is there anything you can actually simplify out? No. Yeah, the answer is no. Okay. So you actually solving this problem, and then the final solution will be this. Okay. Sorry, let me actually reread this part. Maybe you're okay. So the final, now we solve the question 2. We solve question 2. Okay. So let's move to question 3. Okay. Again, you see we have a different denominator, right? Okay. As I tell you guys, you want to find. As I tell you guys, you want to find if you see you have 2 different denominator, you want to find the least common denominator, right? And the least common denominator over here is just simply this one. 1 second. You may ask me why. Because you can see between x plus 4, we can see between x plus 4 and then between x plus 4 and x minus 1, there's nothing in common, right? There's just nothing in common. So the simple, as I tell you guys, as I mentioned before, I say if there's nothing in common, the easiest way is just multiply them together, right? You just multiply them together. So that's our least common denominator for question 3. Okay. So now we find the least common denominator, right? So now we want to make them to have the same denominator, right? You multiply x minus 1 on x value, okay? So you multiply because you want to have the same denominator, and x minus 1 is the missing part. It's the missing part. That's why you multiply it. Okay, that's a simple logic. Okay, and then on the other side we have x minus 1, and then we're missing the term x plus 4. So that's why you multiply x plus 4 and then x plus 4 on the other side, right? So because now you multiply the missing part to make it have the same common denominator, right? So now you can see now we actually having a same denominator, right? So we have to multiply. We have to multiply it, right? Let me do it actually step by step. Okay. So now you can see, we actually getting the same denominator, right? So let me move it down a little bit. I guess we're out of space. So you can see now we have actually having the same denominator, right? So now we are actually able to applying the property of the subtraction, right? Okay. Sorry. Okay, so let's actually doing this a little bit faster. Okay, so you write down the same. You write down the same for the denominator, and then on the numerator, you can see you can actually simplify a little bit, right? Well, we have 5x minus 5, and then we have a negative over here. So we have a minus 3x, and then we have a minus 12, right? Okay, we have a minus 3x and then minus 12. So as you can see, we can actually simplify a little bit more, right? Kind of like auto space. So let's do it. Okay, so we simplify a little bit. So we have 5x and then negative 3x, which is 2x, right? And then we have a negative 5 and then negative 12, which is negative 17, right? So we have 5x minus 3x, which is 2x, and then negative 5 minus 12 is negative 17, right? So now you take a final look. Is there any way you can actually simplify more? And you're thinking for a moment, and the answer is no. Okay, the answer is no. There's nothing you can actually factor out anymore. Okay. Yeah. So that's this is the solution for question 3. Okay. So this is the solution for question 3. Okay. So let's move into question 4. Okay. Question 4. As the question going further, it's getting a little complex, right? But you already getting a better understanding how you actually solving those denominator which is not the same. Okay. The thing over here, the first thing over here, what you have to do is you have to simplify a little bit. Okay, because you can see. So first you see the denominator for those two terms are different. So that means you have to find the least common denominator, right? So you have to find the least common denominator, but you can also see, for the term over here, this term x squared minus 16, it is actually not the simplest form, right? So it makes you harder to actually find the least common denominator. And for this term, x squared minus x minus 12, this also not the simplest term. So it makes you really hard to actually find it. So that's why you have to simplify first. Okay, so we can simplify x squared minus 16 and then make it become x plus 4 and then make it x minus 4. If you have any confused, make sure you're watching my previous video. Okay, and then for this one, all we have is x minus 4 and then x minus 3, right? Okay. Okay, so now you can actually see that. They both have x minus 4 as the common term, as a common term, right? And then they have two different terms, right? So two different terms is so basically since x minus 4 is the common term, it have to be in the least common factor, least common denominator. Okay, so that's why you write down x minus 4 first, and then you can see the one I'm putting it with double line, those are the difference between those two terms, right? So the easiest way to actually find it is just basically write those down. Okay, the easiest way, since x plus 3 and then x plus 4 are different, so you follow the same logic. You are different, so you just multiply them together. Okay, so that's why you just basically put them together. That will be the least common factor among those two terms. Okay, Okay, so now you find the least common factor, right? So now we can actually continue, right? A little bit. So you can see we got x minus 4 and then x plus 4 over here, right? And then we're missing the term x plus 3, right? We're missing the term x plus 3, so you multiply x plus 3 and then you multiply another x plus 3 on the top to make it balanced, right? And over here we have a x minus 4 and then x plus 3, and then as you can see, you're missing the term x plus 4. So you have to multiply x plus 4 and then x plus 4 at the top to make it balanced. Right? So that's how you usually using the least common factor, least common denominator. Okay, so now we are actually able to simplify a little bit more. Okay, so now you can see we have the same common denominator, right? So which means we are able to apply the property, right? So you basically write it down, and then you simplify the top part, the numerator, 5x plus 15 and then minus 3x and then you minus 12, right? So now you are actually able to simplify a little bit more. Let's simplify a little bit more. So we have x minus 4, x plus 4, x plus 3 on the denominator, and on the top we have a 5x minus 3x, which is 2x, and then 15 minus 12, which is 3, right? Okay, 5x minus 3 is 2x, and then 15 minus 12 is is actually positive 3. Sorry, my mistake. Sorry, my mistake. 5x minus 3 is 2x. And then positive 15 minus 12 is actually positive 3. So now you can see, now you take a final look, and then you can see there's nothing we can actually factor out. Okay, so it's basically just right now there's nothing we can actually factor out. So you leave the answer on this list. Okay, so you leave the answer on this list. So now, okay, so now this will be the final solution for question 4. Okay, so now this one will be the final solution for question 4. Okay, so let's moving to the next question. That's question 5. Okay, so now you look at question 5. You see this one is actually quite similar than the last one we actually do it, right? Okay, so I'm just going to show you guys how you actually, I think up on this point you guys should already know how you actually solve this question. So I'm just going to show you guys how you actually solving this, how you is actually solving those kind of questions without a doubt. Okay, as you know getting familiar with this question, I think you guys are actually able to see the answer and then know how to do it straight away. Okay, and I will show you how you actually finish this question really fast. Okay, so first we have to simplify it, right? So we have to simplify because you can see for both those two terms, we have to simplify in order to find the least common denominator, right? So you can simplify in this one, you can simplify it, right? Okay, and for the next term we have y squared minus 1, so it's y plus 1 and then y minus 1, right? Great. So now you can see we have y plus 1 and then y plus 1 as the common term, right? As the, let me move it down, okay? Okay, so as the common term, right? So you know we have to multiply y minus 1 to the other side, right? So we have to multiply y minus 1 to the other side to make it become a least common denominator, right? And you can see on this part we are actually missing y plus 5, right? So you basically have to multiply y plus 5 to the other side, to y, and then you also have to multiply y plus 5 to make it balanced, right? So by using this kind of logic, you can see I actually find the least common denominator already, right? You can see the denominator between those two terms are the same, so we can add, so that makes us easy to actually solving this problem because we can actually applying the property over here, right? Okay, so let's actually move down a little bit. So now we are actually able to do the addition over here, right? So first you write down the common denominator, right? You write down the common denominator and then you simplify the top part. The simplified top part will be 5y squared minus 4y, and then you're doing addition. So on the other side you have 2y squared and then you add 10y. You add 10y, right? Okay. So now we actually finished the simplification on the numerator, right? Okay, so now we have to simplify a little bit more, cause you can see on the numerator you can still simplify many things, right? So you write it down the denominator. Okay, write down the denominator, and on the top side we have a 5y squared and a 2y squared, so it make it become 6y squared, right? And then here we have a negative 4y plus 10y, which is plus 6y, right? Which is plus 6y. Okay, so now we actually simplify a little bit more, right? So now we now you actually thinking about, can I actually further simplify it? Okay, and the answer is yes. So basically, you have to examine the equation. You have to examine the whole term by yourself, and then see is there any way you can actually simplify more, and then over here you can actually simplify more. You can see on the numerator we can actually factor out a 6y and then make it become y plus y, right? And then you write it down the denominator. Okay, let me repeat one more time. So after this way you have to take a look, and then you have to thinking about in your mind, is there anything I can actually factor out more? And the answer is yes over here. As you can see, we can actually factor it become 6y and then bracket y plus y, right? So you can see over here we can actually cancel out y plus 1, 1 plus 1 to actually simplify more, right? Okay, so you always want to simplify as much as you can to actually getting the right answer. Okay, so now we finally getting the answer, right? So now we actually getting the so now on this point you can see now you have to thinking about that I can simplify a little bit more, and you can see there's no way we can actually simplify more. So just basically no way. Okay, so you leave the answer as it is. Okay, you just leave the answer as it is. So this is going to be the final solution for question 5. Okay, so now this will be the final solution for question 5. Okay, so since this one is actually the last question, so pause the video and then try to do this question by yourself. Okay, pause the video. Okay. Okay, so let's do the question together, and hopefully you don't get the right answer. Okay. Okay, so for this question, you can see we have p plus 1 and then p minus 3, right? P minus 3, and the really important point over here, as I mentioned before, is that in order to find the LCD, the least common denominator, we need to have at least 2 terms, right? But here we have 3 terms. So here the thing is that you need to find the least common factor among those 3 terms, right? Okay, so I have one really good advice when you actually if you actually want to find the least common factor among 3 terms. one advice is that you want to make sure you simplify as much as it is. Okay, so let's go through one by one. You can see over here we have p plus 1. That's already the simplest form, right? And then we have a p minus 3. That's another simplest form. But you can see over here this term p squared minus 2p minus 3. That's not the simplest term. That's not the simplest form, right? So first thing, what you have to do is you just basically you write down everything which is already the simplest, and then you try to simplify the denominator of p squared minus 2p minus 3, and it turned out it to be p minus 3 and then p plus 1, right? Okay. Okay, so now we actually simplify all the terms, right? And now we actually simplify all the terms, right? And then you can see here, like p plus 1 is actually a part of it, right? And then p minus 3 is also a part of it, right? So you guys get the idea, right? So p plus 1 is actually a part of the final term, the third term, right? And then p minus 3 is also a part of the last term, right? So which means that the LCD over here is just simply p minus 3 and then p plus 1, right? Okay, so now the LCD is as simple as as this term. Okay, so now you want to make sure you basically perform it, right? You basically perform it, right? So we have a p minus 1 over here, and then we're missing the term p minus 3, right? So we're missing the term p minus 3, so you have to multiply p minus. Okay, so basically we have to multiply, because p minus 3 is missing, so you have to multiply up and down with both p minus 3, and then here we have a p minus 3, and then you can see we're missing the term p plus 1, right? So you have to multiply p plus 1 up and down. Okay, so you basically multiply up and down. Okay, and for the final term, we just write it down because it doesn't miss anything, right? Because you can see for the final term for this term it doesn't miss anything, so we don't have to add, we don't have to multiply anything, right? So now you can see we have the same denominator, right? So now we find the least common denominator, right? We find least common denominator, so that means we can actually let me move down a bit. So that means we can actually we are able to apply property, right? We are actually able to apply property. Sorry for the miswriting. Okay, so we have p minus 3, and then we got addition over here, plus p, and then plus 1, and then we got a negative. Okay, this one is so bad. Minus 4. Okay, so now we able to simplify a little more. Okay, p and then p plus d is 2p. Okay, negative 3 and then positive 1 and then negative 4. So it's just basically become negative 6. Okay, so sorry. 1 second. Okay, it's over here, sorry. It becomes -6. Okay, so let me actually zoom in a little bit. Okay, so let's go back on track. So here, right? So P plus P is 2P over here, and then -3 and then +1 is -2. -2 and then -4, so it's -6. Right? So now we take a look. Am I able to simplify more? And the answer is yes. Okay, the answer is yes. So you can actually simplify a little bit more. Okay, I'm kind of like out of space, so I think I'm just gonna yeah, we're gonna write it on something over there. P plus 1 and then P minus 3, and then the top part we can actually top part we can actually simplify a 2 out of it, right? And you can see you can actually cancel P minus 3, right? You can actually cancel P minus 3. That makes our final solution as P plus 1 over 2. Oh no, sorry, it's actually 2 over P plus 1. Okay. So our final solution for this, for question 6, yeah. Let me, orient it to make it a little better view. Okay. So now our final solution for question 6 is actually 2 over P plus 1. Okay. Hopefully you guys get this question right. Okay, and fully understand it. Okay, so how to using least common factor to actually solving those problems. Okay. Okay, so thank you guys to watching this video, and hopefully you learn something from it. Okay, and hopefully you does learn something from learn something from it. Okay. So make sure you also subscribe to my channel, and then leave a like button if you find those videos are really helpful. Also leave a comments. Okay. Subscribe to my channel, leave a comment, and okay. Yeah, if you still have some problem, then please leave a comment. Please let me know. Okay, I will try my best. Okay. Otherwise, yeah, thanks guys watching this tutorial.